The next couple of videos are going to look at something very interesting around the topic of artificial intelligence. We're going to see two subfields of artificial intelligence, mainly sentiment analysis and linear regression, to see how we can use these concepts in doing data analysis for our data sets. So like always, I opened up my Anaconda Navigator and launched Jupyter Lab. This local interface opened up for me, and now I'm ready to open a new notebook. So I created a new notebook, and I'm going to rename this Artificial Intelligence. So before we even start coding, it's always good practice to explain what this document will be about in plain English sentences. So we're going to start by talking about AI. We're going to say it has many subfields. The first one we're going to look at for this video is natural language processing, or NLP for short. And NLP deals with sentiment analysis. So what does this word sentiment analysis mean? Well, sentiment analysis looks at the tone of words or sentences and predicts their emotions. So a key thing to note here is that these words and sentences are free-form text. And this is very different from what we've seen so far, where we're only dealing with structured data in the form of numbers, integers, or floats. So now we're starting to look at things that cannot be categorized very easily, but we can still find out useful information. Specifically, we're going to look at something called VADER. And VADER is a library that's available through Python, which allows us to do sentiment analysis on text. So how do we actually start using VADER? Well, just like with most external functionalities of Python, we usually have to import these things. We're going to import VADER. VADER comes from this library called VADER Sentiment, and specifically, we want VADER Sentiment in this library. Hence why I'm writing .VADER Sentiment. And from VADER Sentiment, I'm going to import the sentiment analyzer. So what does this do? Before we go and fix this error, in this import statement, we're basically importing sentiment intensity analyzer from the VADER sentiment library. The VADER sentiment library has many different functions, of which one of the functions are VADER sentiment. And this VADER sentiment allows us to access the sentiment intensity analyzer. Well, when we ran this function, we weren't able to get an output that was without errors. Specifically, it's saying module not found. So if you're getting this, it usually means that Python doesn't recognize what VADER sentiment is. So for that, we have to first download it in our local computer. And here's the syntax to do so. You have to write !pip space install and then the name of the module or library, which in this case is VADER Sentiment. I'm going to press play, and now it's fetching the necessary packages for us to be able to use VADER Sentiment. And here we get a successfully installed message. So if I run this again, I don't get any errors. So how do we actually use the sentiment intensity analyzer? Well, first we have to store it in a variable. And notice how I'm opening and closing brackets here. And that's because it's a function. And we're going to access different methods of this function using this variable called SA, which is sentiment analyzer for short, or sentiment analysis. So specifically, we can store an instance of the sentiment intensity analyzer in the SA variable. So let's look at a very simple example. If I want to use the sentiment intensity analyzer, I can just call SA, which is our variable, and type polarity underscore scores. Notice how this lights up, which means that Python recognizes it as something special. And here I can just pass in some free-form text. Maybe I'll write something like, I don't like Monday. And if I press run, I get a few scores. I get something called neg or negative, new or neutral, pause or positive, and then we have something called a compound. So a compound score is the ultimate quantitative measure of the sentiment for this sentence. Sorry, I think I typed it wrong. Let me run this again. And now you see how the negative score really increased. So let's quickly document what were the different values that we got. We got negative. So negative ranges from 0 to 1. So we can have a score between 0 to 1 for negative. We also have positive, and it also ranges from 0 to 1. We have neutral. This also ranges from 0 to 1. And then this compound value that I previously mentioned, you can sort of think of this as a unidimensional single value that gives you an overview of the overall sentiment for the text. And its ranges differ from these three variables. You see that we already have a negative value here. So the compound score is a unidimensional single value that gives you an overview of the overall sentiment of the text. The emphasis is on overall. Its values range from -1 to 1. So we can have a compound score of -1, which means the overall text was very negative. Or we can have a compound score of 1, which means VADER thought the overall sentiment of the sentence was positive. The closer it is to 0, the more neutral the sentence is. So let me just show you another example quickly. Instead of writing, I don't like Mondays, I'll change it to saying, I like Mondays. Notice how now the values are much different. Previously, our compound score was -0.27. And with, more positive sentence, now our compound score is 0.36. And our negative score is also 0, whereas in the previous case, we had a 0.41 value for the negative score. This seems very useful. We can pass it a sentence, and it gives us some numerical value for the sentiment of that sentence. Here's the question. Can we use VADER in datasets? Well, of course we can. And now we're going to see how. So as always, when we're talking about datasets, you really want to import pandas. I'm going to use a US inaugural address dataset, which stores the inaugural addresses of all the US presidents. If I go inside my datasets folder, I see this CSV file called clean inaugural address. So we see the names of the presidents, the date when they gave the address, and then the text. So this is their speech. So let's import this very quickly with pandas. We already know how to import datasets using pandas.read CSV and then passing it the location of our dataset. In this case, it's stored in a folder called datasets cleaned inaugural speeches.csv. So if I check a few samples of our data, we see something very similar. We see the name, the address, the date, and the text. But the text is sort of cutting off. Let's take a look at, a case where we can see the full text. Name a variable called the text of first row. And we already know how to focus in on a specific column. We simply use square brackets, and now we are focused on the text column. And we're only going to take the first row, the indexing value of 0, since Python starts at 0. Now if I run this, here is our speech for the first inaugural address. And it's quite long. We can't really make quantitative sense of it. There's no numbers for us to sort of analyze, but we can still do sentiment analysis on this to get an idea of how VADER thinks the tone of this overall speech was. Was it overly positive? Was it overly negative? And so on and so forth. So we're going to calculate the polarity score of the first row, mainly this whole piece of text. So we can pass it a very large paragraph. And it very quickly gave us a sentiment score. The compound score was very close to 1, which means the speech was overwhelmingly positive. Let's take a look at another case where we sort of randomly, instead of choosing the text from the first row, let's just pass in the text of, say, the 10th row. So you see that the values differ slightly, but overall, the compound score is also very close to 1 for this speech. This is the speech that's stored in the 10th row. So how can I run a sort of polarity score calculation for all the rows of this dataset? Well, how many rows do we actually have? So we can run df.shape to quickly check. We have 58 addresses or speeches. And what I want to do now is calculate the polarity scores for each address. So instead of doing it manually by writing, calculating the polarity score for 0, then 1, then 2, and 3, and 4, and so on and so forth, we're just going to create a for loop. And inside our loop, we can easily have it check the polarity scores for each text. So let's quickly write what is our task. So we want to make a for loop to look at all texts for the dataset, to look at polarity scores of all texts in the dataset. In each iteration of the loop, we can run this polarity scores function on the text for that row. So let's start writing our loop. We start with for, and I'm going to say index, and I'm also going to initialize a row. And the way to really go through your data set in a for loop fashion is by using this syntax, writing the name of your data set and then writing iter rows. So iter rows really stands for iterate rows. So we're basically iterating over the rows, and for each row, we're going to calculate the sentiment analysis. SA for row is a new variable that we will create at each iteration, and it's going to be exactly the same code as this, but instead of having 10 here, we're going to write row here, because what this loop really does is it focuses on the first row, and then for the first row we're saying we want the text, and then it does the same for the second row. So this is what this code does. And I don't just want to calculate it, I also want to print the value. I'm only going to print the compound score. So let's see how we can do this. I suppose I should be using f strings, and I'm going to write the sentiment analysis for row and give the actual row number, which is index +1. I'm writing +1 because, Python starts at 0. So we want it to be more readable to non-technical audiences as well. So really it's going to say the sentiment analysis for row 1 to start off is, and then we're going to pass in whatever value we have. So if I run this, let's see what we get. So this is actively running as I'm talking, and it's calculating the sentiment for each row. We should have 58. But it's giving me all of these extra numbers that I'm not looking for. I only care about the compound score. This loop is over and, it ends on row 58. I'm going to modify this a little bit and write. So I'm sort of treating this as its own table. Now we're only getting the compound scores. VADER characterized most of the speeches, if not all, as a perfect 1 or very close to 1. Do we have any outliers? So on row 20, we see a speech that, had a very negative compound score, almost close to -1, which is the worst. So I'm sort of curious to see what was the actual speech for this row. We know it's row 20, so in other words, it's 19. So I'm just going to focus in again on the text column and print the 19th speech. Right off the bat, I can see words like war, battle. So there's so many words here that sort of give the speech an overall negative score. And VADER was able to capture that automatically.